Hello everyone, welcome to another YouTube video where control systems are made easy and fun. So we start off what are control system, but before we get into what are control system, we first need to verify what is a system. So a system is a collection of things that are put together with the intention to perform a specific task. So whereas we say what is a system, we're gonna say what are control systems. So control system is a system we use devices and processors to control their behavior. This system contains three main components: a sensor, a controller, and an actuator. Very simple. So we'll move on to the next slide.
So on the next slide, we have some examples that would help to further your understanding of what a control system is. So as it says, control systems can be applied in a wide range of things. For example, manufacturing, transportation, energy production. In manufacturing, you would be your assembly lines, your car lines. You put together parts of cars and then send them out to customers who are willing to purchase. Transportation, traffic light, one input, one output. Input being electricity and output being your red, green, and yellow light. Energy production, JPS, they put in high voltage within the system, and then you have your power stations that break down that high voltage into smaller voltages and send it out to customers. You can find them in a lot of modern devices and systems and are used to maintain stability and manipulate behavior. Moving on to the next slide.
What is an open loop control system? These systems do not use feedback, which means that the output is not influenced by the actual performance of the system. Instead, the input of the system is predetermined based on a set of predetermined rules or instructions. This can make open loop control systems less precise and less responsive to changes in the system or in the environment. What is a closed loop control system? Closed loop control systems are also called feedback control systems. The control action is based on the intended output. A closed loop control system may include one or more feedback paths.
How do these systems differ? In open loop control systems, the feedback element is absent, it is inaccurate, it is unreliable, and lastly, it is not expensive. While in closed loop control systems, the feedback element is always present, it is accurate, it is reliable, however, it is costly. So basically, both systems differ in terms of accuracy, where the closed loop is fitted with a feedback system while the open loop isn't. This feedback system regulates the input if the current output doesn't meet the desired output that is needed for the device or process, in turn making those devices or processes more accurate. And now we move on to components found in every feedback system. So there are 5 stages or 5 main steps. We have the stimulus, we have the receptor, we have the control center, the effector, and response. To better explain this feedback system, I'll be giving 2 examples. One with the use of a smart oven, and the second with changes in the human body. For the first stage in stimulus, for a smart oven, a change occurs in the environment, like the oven temperature dropping below the desired setting. This change is the stimulus. For the receptor, a sensor inside the oven detects the temperature drop. This sensor acts like the machine's receptor, gathering data from the environment. Next is the control center. The sensor sends this data to the control unit, essentially the machine's brain. then the control unit compares the actual temperature to the target temperature. For the effector, if there's a difference, the control unit sends a signal to an actuator, like the heating element, to turn on or adjust its output. And lastly, for response, the heating element increases the temperature, bringing it back to the desired level. Once the target is reached, the system may reduce or stop the heat to maintain balance. So this loop essentially is how machines self-regulate, not only ovens, but also in the industrial environment. It's a core principle behind automation, robotics, and smart technologies. A more simple example would be for the human body. So the stimulus could be a change that occurs in the body due to environmental factors such as temperature. The receptor detects the change, then control center, your brain receives information and decides what to do. For effector, it carries out the response, example, sweating to cool the body. For response, it restores balance and returns the body to its normal temperature.